And welcome to Daily Space Weather, folks. Looking at the sun here in 304 angstroms. We see some filamentary dance behavior going on in the south. Let's take a look. This is 8.5 hours of the local yellow dwarf today on January 16th, 2020. No sunspots, and we see some fairly dense solar wind coming in. A couple big spikes where we're getting up to over nearly 100 protons per cubic centimeter. We'll get to it in a minute. First, let's look at the 193 angstroms view. Here's the north. And there is a diffuse coronal hole region down here in the south, moving into the Earth-facing area right now. Again, we're looking at 8 hours and 45 minutes of activity here, and there are the time and date stamps. I want to just cite one thing that I noticed on HelioViewer. By the way, here's the active setting region. See those giant filamentary magnetic loops sticking out there? I've created a custom video here on HelioViewer, and this is from the 14th, and you're going to see a plasma explosion happen here. And that material does appear to have splashed back down on the surface. It didn't appear to go out into space. We looked at it from the perspective of stereo A and so on. I'll let that play through a second time so you can see it happen. It initially kicked off at about 9:30 Universal Time on the 14th. You can make your own custom movies in whatever wavelengths you like if you head to helioviewer.org. Anyway, I just figured I would add that little section, as this will be something in future upcoming videos that will feature more often. And there you see that release of plasma there in the 171 angstrom view. And let's move on to some more data here. The X-ray flux, pretty flatlined there. And solar activity quite low. 10.7 centimeter radial flux has dropped back down to 71. So quite low levels of solar activity, folks. Again, no sunspots, no real active regions going on. But the solar wind generated by the coronal hole wind stream that we're currently in has gotten the KP all the way up to 3. So we'll see if that gets to geomagnetic unrest conditions, which start at a KP of 4. The network of cosmic ray stations site is back up. I don't know if you noticed it was down yesterday or not, but if you want to monitor cosmic rays, feel free. If you notice anything weird, drop me a line at smAsho@gmail.com. Here's a real-time solar wind, and we see the phi angle shifting all over the place as the magnetosphere is buffeted by a coronal hole wind stream. No real surprises there. And we see lots of instabilities in the plasma density here, ranging all the way from 71 protons per cubic centimeter all the way down to 3 protons per cubic centimeter, 2.5. And we see that density finally dropping off now, which means perhaps the solar wind speed has not finished rising yet. Anyway, the current solar wind density at 3.26 protons per cubic centimeter, solar wind speed 376 kilometers a second. And it's probably still rising. I wouldn't be surprised to see us get into geomagnetic unrest. And there's the data from ACE looking similarly. Electrons have dipped a bit. And there's the GOES electron flux, which is now cratered once again, as we forecasted once again. Please leave a comment if you think other space weather channels are forecasting electron flux. Hint, they aren't. Here's the F2 map, the F2 ionosphere, the entire F layer, which, by the way, where you see these red blobs, that's an F layer. There is no double layer in those areas. And then starting at 2 megahertz, you've got an F2 layer, F3, and so on. As the Van Allen belts press on the ionosphere, and we won't get into the physics of how that works today, but anyway, there's the data. Let's bring up the latest image. That one at 9 o'clock. And we continue to see anomalies in the South Atlantic, off west of South America, in this region right here, around 120 degrees longitude by 30 degrees latitude. And the magnetometer is kind of all over the place right now, and that's because of that coronal hole wind stream. Remember, folks, plasma blocks the magnetic fields and obscures them, and that messes with the readings in the GOES magnetometer. It's not because the plasma is a magnet. The plasma is orienting to the fields. The plasma orients to the fields, folks. That's just the way it works. We can go round and round all day about it. Chicken versus egg arguments. Now we're looking at the Gong 2 data here, and it's 9 hours and 9 minutes old. And so it's not particularly useful, although we will remain in the South Pole oriented portion of the current sheet shown here in red. And that's the heliospheric current sheet for you new viewers. And thanks to the new viewers for tuning into the Daily Space Weather videos. Not a lot to comment on there. Here's where planets are in the solar system. And no, I don't think they influence solar activity. I think they are correlated with solar activity, because the sun is not in charge of its own fate, just like the planets are not in charge of their own fate. There's where things will be in 1 week, as Venus is finally making its way around to this lonely side of the solar system, and we approach another new moon. I always like to know what's going on above my head, so I like to go to in-the-sky.org. Look at a sky chart. Mars will be rising soon. Do you have a low horizon and a telescope? Get us some images of Mars. It'll rise around 5 o'clock if you're on the east coast of the U.S. And let's move on to the geospace magnetosphere movies. And we see some serious pressure here, and that's all induced by the plasma density and speed of the solar wind. So you'll see some pretty wild striations here. And I don't know if it's going to refresh. There you go. There's some pretty big spikes in the geospace magnetosphere movie there. High magnetohydrodynamic pressure coming in as a result of those density spikes. I'll let it play a second time. And that's 4 hours of data courtesy of University of Michigan geospace model. And it refreshed. I apologize. I'll just let that play through. Before we move on to the geospace ground magnetic perturbations, and we see wild magnetic perturbations in the ground. Let's get to it. And you're going to see this jumping all over the place. And that's caused by those striations in the solar wind, folks. These are geomagnetic jerks. And by the way, nice move, Ben Davidson getting on the Glenn Beck show yesterday. They've tried to put me on a few times, and I've either gotten disconnected or had to leave before I was taken off hold. So anyway, there are those big spikes. Let's actually look at the polar view for once. I'll let that play through once again first, and then I'll show you the polar view. If it would stop refreshing, I would be very delighted. And again, this is 4 hours of data here. And you'll see those wild spikes coming in at the same time as we measure the solar wind density there. Here's the view from the poles. And you should see a spiral-like pattern, as there are Birkeland currents coming into and going out of both ends of the planet. And it is an odd time of magnetic excursion on this planet as the South Pole creeps toward the southern Indian Ocean, and we've got 2 North Poles. It's an odd time to be around. Let's look at the earthquakes of the past 24. Puerto Rico's been struck again. Shout out to Peter Schiff. Hopefully everything is working out okay down there. And let's just scroll up the list. No 6+ magnitude quakes. We see a bunch of quakes on the west coast of South America now, and no surprises there. There's that 5.2 striking Puerto Rico. Now we do see one in an odd spot here. This one in China, very far inland there, not really near any known plate boundaries. Let's just continue scrolling up the list here. A low magnitude deep quake at Alaska. There's a deep quake at Peru. That's a 4.6 magnitude at 101 kilometers. And really, we are still in a 7+ magnitude earthquake drought, folks. So personally, I would have an earthquake plan if I were you, especially if I was in a highly earthquake-prone location. Please have a plan. Be an asset, not a liability, in the event of a disaster. If you're wondering who the cavalry is, it's probably because it's you. Let's look at the pressure maps. And the U.S. is dominated by high pressure right now. We'll just let this advance about 24 hours here via the GFS forecast here on windy.com, who has a wonderful mobile app, by the way. And here's midnight Zulu as the high pressure moves out toward the Atlantic. And there's where we anticipate things to be based on the GFS forecast at 12 Zulu tomorrow, 12 Greenwich Mean Time, Universal Time, whatever you want to call it. And here's the volcano rundown. It includes Mount Aso. Let's do the whole list. Uptick at Kluchevskoy on the Kamchatka Peninsula, producing a 23,000-foot ash plume. So there's an uptick there at Kamchatka. Mount Aso, 6,000-foot ash plume there. Mount Tal still erupting, producing a flight level of 2,000 feet. Explosive activity at Dakono, producing a 7,000-foot ash plume. Not observed is Sangay's ash cloud. If there is one or not, we're not sure, probably because of clouds on the satellite image. Revenador sporadic emissions as it mildly explodes. I don't know what's mild about an explosion, but while Sabancaya is unable to detect whether or not it is erupting, please do not attempt to pole vault Sabancaya's caldera, as that could be a bad day. And we see a pretty intense lightning storm here in the eastern Mediterranean. Let's zoom in. If you're an economic migrant trying to cross the Mediterranean right now, it could be a bad day. It's looking stormy. Anyway, check out lightningmaps.org if you are concerned about lightning. And here's the U.S. jet stream situation. We see a convergence right over the central U.S. there. No surprise, as it's causing high pressure. Not a jet stream level anticyclonic system. Let's look at the whole western world here. And there's the jet streams of the west. Extreme meridional jet stream flow there over places like Alaska, where the jet stream is making a 180-degree turn. Down here in the south, it's flowing the wrong direction over central South America. So anomalies continue in the jet stream year after year, folks. If you think CO2 is causing the jet stream anomalies, please unsubscribe from our channel. Just kidding, folks. We'll teach you all about atmospheric physics. Anyway, here's the U.S. Doppler radar, courtesy Weather Underground. Is it named after a terrorist organization or not? I'm not sure, folks. Please leave a comment. Anyway, we consider that a value-added service, so enjoy that. Here's the water vapor map. If you're not sure what's going on with the Doppler radar, take a look at a water vapor map. It will give you insight into what is going on up there. Looks like Bermuda's getting some sudden evaporation happening. And let's just take a look at this area over the Gulf. And there's that convergence of dry and wet air in the Gulf. No forecast there, folks. This is just for the fun of it. Also, let's look at this area right here over Arkansas, Texas border. And let's move on. But first, I would invite everybody to please press like and subscribe on YouTube. Share our videos on your social media. Perhaps you could learn something new about physics. Who knows? Thanks, smAsho team, for tuning in, leaving comments, etc. And stay tuned for some bonus features. We're going to talk about the smAsho forum here. Thanks everybody who has signed up for the smAsho forum. We've got a post while I did the show today. Let's talk about some of the posts. Shout out to Terrence. Well done, Terrence. He's kind of our human health editor right now. And he's been putting up all kinds of stories about things like intermittent fasting. Here's this great graphic that he put up about fasting benefits over time. And we're not going to link to that at all. Just say head to smashamash.org. Scroll down, click on the newly unveiled forum link. He's even got information about how to store your coffee. Let's play a teaser.
Hey guys, it's Alex from European Coffee Trip, and in this...
Once you grind the coffee, then you have to use it immediately.
Once you grind the coffee, then you have to use it immediately. Now that's one to grow on, folks. Let's talk about heart rate variability. Apparently, heart rate variability is super important in the way that it relates to all kinds of diseases. Now, while it's been used for many years to diagnose things like diabetic neuropathy, it's seeming more and more important. Here are my comments about it. When pro cyclists are in top form, our resting heart rates get down to about 20. I've personally measured mine at 23 beats per minute. At the same time, my max heart rate was about 205 beats per minute. That's called high variability. When training, one way to determine if you're overtrained is by noticing lower heart rate variability, in that when you're overtrained, your heart rate will not rise as readily. We're not sure of the mechanism, but in light of this information from Terrence, I have a theory. Inflammation is an issue during maximum training cycles. Considering how many other conditions are associated with low heart rate variability, it is likely yet another inflammatory marker. Basically, it doesn't matter what the underlying mechanism is. Reduce inflammation and live longer. So check out the forum. It's got all kinds of interesting information. And here's our final bonus feature. We're going to look at the 48 hours of the local yellow dwarf in the 94 angstroms wavelength. So we are out. Thanks for tuning in, everybody. Remember to stare at the sun, and when you do so, don't drink, and if you drink, don't drive. And since it'll never be now again, may that solar wind be at your back and that atherosclerosis absent from your veins.